So today we are going to discuss something about the Banker's algorithm. So in the previous class, we had a discussion regarding to how the things are being happened when resource allocation could be there. What is the avoidance kind of state which is being available with you, and how could you get the safety state from the resource allocation for several number of processes? Already we have seen. And while we are trying to apply Banker's algorithm, the resource allocation graph will be improved with one more extra edge. That edge is called as a claim edge. Claim edge. So what do you mean by claim edge here in the sense? For example, a claim edge, PI is let me say, we are talking about the processes, I think. So PI is requested towards the RJ type, resource type RJ, indicates that the resource PI is requested requested the resource type RJ sometime at some time in future. So simply speaking, a reservation which could be able to done. So that reservation could be occupy that particular reservation in future, something like that. So as far as the edge which is being seen, something like this here. So let me say PI, so requesting a resource type RJ, it will be seen something like this. Oh, sorry, it is actually square box. Now it could be seems a dotted line, dashed line. If dashed line will be there with you, then it will be requested towards RJ at some time in the future. When, as far as the Banker's algorithm or resource allocation graphs are concerned, so in future, probably at delta T naught time, so the session was started, the execution was started. All the executions were started at delta T naught time. PA also taken its execution at delta T naught time. So execution was started here. At that moment, resource type RJ is not required to finish off its job. So time is being continued. At delta T5. So resource type, process PI now required to have this particular RJ. Now PI now required to have the resource type RJ. What exactly it is going to do here in the sense? So these are the steps which are going to be done. So when claim edge will be required to have by any particular process in the sense that a claim edge will be number one, the claim edge will be converted to request edge. After claim edge will be converted into request edge, immediately that request edge, not the actually, that request edge, whatever the claim edge which was converted to request, that request edge will be converted to assignment edge. Yes, assignment edge. So what are the in pictorial? What we are supposed to show here in the sense at a particular certain amount of a certain piece of time. So as far as the process which is being taken before going to start its execution or before going to enter into CPU for execution, so it will be provided some information to the operating system that yes, I need one particular resource type RJ in future, something like that claimage will be taken. Soon, when it is actually required, what exactly? So the thing will be done here in the sense this particular edge is going to converted something like this is PI is being so requested RJ. When it is requested, claimage will be converted from claim to request. Then immediately, what exactly? So the thing is being done here in the sense request type RJ is being allocated to so the process PI. So it will be done here. So claimage will be first converted to, so first operation to be taken into consideration will be, first operation is this one and the second operation will be this one here. And of course, your process will continue. So that claimage will be converted to request and request will be again converted into assignment edge so that your process will be continued. So these are the, this is the extra edge which is available for you to execute your process in terms of banker's algorithm or resource allocation graph here. So this must be required. This must be required. So let me wait for a while. Yesterday also the same thing was happened. Just one moment, please. Okay, let me copy everything right away from here to the top. Okay. So yesterday also I did the same mistake. Okay, however, so this is the thing which is being happened here. So claimage is required for performing the banker's algorithm here. So this is the point of the claimage here. This is the point of the claimage, which is being there with you. Then followed by, so claimage in the sense, it must be, so request a particular resource type in future, sometime in future. Okay, it must be done in future. So that's very important. Claimage will be represented something like this here with the dotted line. And when claimage will be so really requested by the really acquired by the process of a resource type RJ, then what would be happen here in the sense two different operations are going to be took place here. Operation number one is this one here. So the claimage will be converted to so request edge. Soon the converted to request edge immediately this request edge will be claimage in terms of request edge will be immediately converted to assignment edge so that pictorially so it's been converted to this one and immediately it's been converted to this one. Obviously our process will be gets completed. So this is the actual scenario where exactly resource allocation graph to be taken into consideration in terms of so resource allocation graph in banker's algorithm. Okay, this is the first point you need to mention within banker's algorithm. Now, the name itself identifies. So look at this. This is the particular name, banker's algorithm. The name itself indicates that how the bank is being worked. The same scenario will be took place with the algorithm as well. So bank might be having some amount of cash in their what you call in their khajana, something like that. And many number of customers are supposed to come to bank and they're trying to. So some customers are trying to deposit the amount, some customers are trying to withdraw the amount. If withdrawals are very high, so immediately those withdrawals are not supposed to be done. Why? If the funds are not available in a proper way, all the customers are not supposed to be served in a proper way. Probably many number of customers are supposed to become right away from 10 o'clock to evening, let me say 2 or 2:30, something like that. So therefore, people are supposed to be enter into bank and they are trying to so put forward one particular leaf that leaf will be so withdrawal leaf. Of course, deposit there is no problem, but withdrawal leaf will be taken by you in the sense if funds are properly available, then they will be allocated. If funds are not supposed to be properly available, proper. What do you mean by proper here in the sense? If I would allocate some 10 crore, 1 crore rupees to one particular fellow, remaining people who are, raise the requisition for some 1,000 rupees, 10,000 rupees, or 2,000 rupees, something like that, they will be just wait for huge amount of time. Okay, so that is why. So based on the amount which is available within the bank, every customer must be so served in a proper way. The same procedure will be followed here. Everything will be gets followed by here by this particular so bankers algorithm in terms of so this particular thing as well. How this could be? Point number one to be understand in terms of so bankers algorithm is first point is when any process try to take this particular thing when any process enters into the system, simply speaking ready queue for execution, it must be declared. So this is very important point. It must be, so I'm talking must be, it must be declare, it must be declare maximum number of instances, maximum number of instances of each resource type, of each resource type of each resource type that it may be needed. Okay, this is the first point you need to understand. So here you could understand one particular thing here. The point will be when a particular process is enter into the system for its execution, it must be declare DSCL area, declare so maximum number of instances of a resource type must be so declared. So this is very important while we are trying to do something with the banker's algorithm. And ensure that, second point, ensure that this number, why? Sorry, while I'm writing, touchpad is being touched. So that is why. Okay, however, ensure that this number may not be, whatever the maximum number, whatever the maximum instances which are required by the process, that particular number, that number, oh, not that, this number, so THIS, this number may not exceeds the total number of resources, the total number of resources in the system, okay. So this is also second point we'll understand. So before enter into the system for its execution, it must be declared how many number of instances of a particular resource must be mentioned. And if you mention something that should not be so exceed the total number of instances of that particular resource within the system. For example, you require the assistance of two printers, but in the system only one printer is there. So you are not eligible to execute anymore. Okay. Then you require two different types of input devices, namely, so this keyboard and mouse. System also having those two. Yes, you will enter into the system and execute your process for a while. If anything is not matched or anything is not meted, then you are not supposed to be enter into so that particular system. Otherwise, you will make your resource requisitions in a proper way that the so second point will be get satisfied. Okay, you must make such kind of arrangements in your process. You must make such kind of arrangements and come back for its execution. Okay. Third one, I hope that you understand. I'm giving very slowly. You got the points, I think.
Yes, sir.
Hmm?
Yes, sir.
What about remaining?
Yes, sir.
Hmm. Dnat and Vijay. ఇది మాట్లాడరా మీరు? I think
Yes,
Vijay is
sir.
not here. Vijay not here. Shall I eliminate him?
సార్ ఉన్నా సార్
మరి ఉంటే
డ్యూటీ
మాట్లాడాలి
టైం
కదా సార్.
పడుతుంది సార్
మాట్లాడాలి కదా సార్, మరి
డ్యూటీ
అడుగుతుంటే
టైం పడుతుంది
మాట్లాడరా ఏంటో.
సారీ సారీ
So that is the point here. When, so these are the 2 points before enter into the particular execution. Now third point to be remembered while we are talking something about bankers algorithm, when user requests a set of resources, so the system must determine, the system must determine whether the allocation of these resources, whether the allocation of these resources will leaves safety state or not. Not it leaves safety state or not. This is the third point you need to remember. Okay. So when system is when user is or process is request some set of resources here, always the system must be identifies or determines whether allocation of these will be in safety state or not. If it is in safety state, yes, you can, there is no problem, allocation will be done. If it is not in safety state, should not be allocated, the process must be in waiting state, should not be allocated. If state is safety state, so in continuation, so full stop. If so, in continuation, if so, allocate them, allocate resources. Otherwise process must wait, till enough resources are available. So you need to understand these three statements. These three statements are very important. So that is why I have spent much amount of time, lot time on these three statements here. These three statements are pretty much important. When a process enter into the system, it must be declared maximum number of resource instances will be declared, will be given to the operating system. And operating system also ensures that this number of resources which are not exceeded, which are available with the resource type of the particular system. So that must be done here. So things will be okay. So far, so good. Now, at this particular point of time, so any requisitions will be made. So so-called execution was started, and then requisition was made by the process here, and this requisition will be leaves the safety state. No problem. They can be allocated. They can be allocated immediately. If it should not be leaves the safety state, obviously it must be wait until enough number of resources are available for its continuation of the execution. So this is the procedure. Okay. So based on this particular procedure, banker's algorithm can be worked out. If you do understand whatever the discussion I have made after this particular heading, banker's algorithm heading, oh, not exactly this one here, this particular thing from 1 to 3, then I shall continue with the banker's algorithm. Please confirm me.
అర్థమైంది సార్.
అర్థమైందా?
No doubt, sir.
Yes.
Okay. Okay. Now, banker's algorithm can be done, can be implemented using several number of data structures. Now, you must concentrate what I'm speaking for coming 15 to 20 minutes. It's very important to understand. So, banker's algorithm will be uses several number of resource type, several number of data structures. The data structures will be seem something like this here. So we are supposed to mention a particular value n. N always represents the processes. Number of processes which are available. That is the meaning of n. And of course, n will be represented with I as well. So I equal to 0, 1, 2, 3, 4, 5, 6 and so on n. Okay, where I will be equal to 0, comma 1, comma so 2, comma and so on, comma n. So I will be always used to represent the processes. And if you want to specify number of processes in the name of I, you would like to represent with n. Where m, one more kind of thing, that is m will be always represents the resources. It should be also replaced with a particular another variable, that is j. J will be equal to some number of resource types. So however, a 0, 1 resource type 0, resource type 1, 2 and so on. So m here. And you would like to use one more kind of variable. That variable will be equal to k, where k will be the maximum number of available resource type instances. Resource type instances will be taken by this particular k. For example, it is not correct actually. For example, let me write to understand for a while. So here r of j will be equal to k does means resource type rj are having k number of instances. That is the meaning. R of means printer 1. So resource type printer is equal to 1 means only one printer is available. Resource type so CPU cycles will be equal to 3.4. So petahertz in the sense those many number of petahertz are available with you. That is the meaning of the k here. K in the sense number of instances which are available for a particular resource type. So first of all, you need to understand these 5 variables: variable m, variable n, I, j and k. Now, what are the data structures which could be used here is, first one is very important, available. Available is a single dimensional array. Available is a single dimensional array having length with m, indicates which indicates number of available resources. Okay, resources of each type. Okay, resources. Okay, let me write of each type. Of each type. For example, you will say available of j will be equal to k in the sense. What do you mean by this one here? Resource type Rj does have k instances. That is the meaning of this available. Resource type Rj does have k instances. That's the meaning of this particular available data structure. Okay, that is the meaning. Then second data structure, maximum, max. It is actually a matrix. It is a matrix of n by n kind of n by m kind of matrix. N by m kind of matrix defines maximum demand of the process, which will be defines maximum demand of the process. Look at this. Let me write something like this. So, for example, maximum of I comma j. Let me write in terms of C notation will be equals to k. What do you mean by this one here is a process pi. So requires, not requests, requires so k number of resource type Rj. That is the meaning. Requires to finish off its job k number of resource type Rj. That's the meaning. Okay, that's the meaning regarding to. So maximum will be defines how many number of resource types of the individual instances are required. So that will be maximum demand of the process. 2 printers, so 1 gigahertz of so processor speed, and then some certain 1 MB of memory and 1 gigabytes of memory in hard disk, something like that. All these things will be gets required by the process to be finished. And then followed by next data structure will be allocation. It is also n by m data structure. Let me say matrix, n by m matrix defines the number of resources which are allocated, allocated to a process, So this is the statement actually. Within this particular statement, what exactly you are supposed to give some example here is allocation of, for example, allocation of I comma j will be equal to k. What do you mean by this one here is process pi was allocated was allocated k instances of resource type Rj. That is the meaning here. Allocation of I comma j equal to k. What do you mean by this particular thing is here is Pi was allocated with k instances of resource type Rj. That's the meaning. And the last but not least, need of so need in the sense it is also a n by m kind of matrix. It is also n by m kind of matrix indicating remaining resources needing remaining resource need to the process to the process. So look at this. Already I have given some information, pretty much important information, that is claimage. Claimage is always trying to request in future, not exactly now. So that is why need will be comes into the picture. Otherwise, there is no need operation here. Okay. I hope that you would understand. So look at this. For example, so need of I comma j is equal to k. What do you mean by this one here is process Pi still need so k instances of resource type Rj. That's the meaning. And you need to understand one more point here, one more extra arithmetic operation here. Need is equal to, how you can get the need here? Need will be equal to, so let me write need of I comma j will be equal to maximum max of I comma j minus allocation of I comma j. If you take this particular kind of equation, then you would understand what is need. Some maximum number of resource types has been needed by the process Pi, and some were allocated. 10 was needed by me, but 4 was allocated. 6 more needed for me. So these are the 4 data structures which are required here. These are the 4 different types of data structures which are required here. So here you are expected to consider available. These are the number of instances for a particular resource type which are available within the system. Resource type J does have k instances. Only these many number of things are available for me for the system. And the maximum for a particular process, wanted to complete my particular process, I require k instances of Rz type will be required by me. So that is why it is a matrix. This matrix will be gives you maximum for I comma j equal to k. That means maximum number of demand for a particular process on resource type Rj will be defined something like this. Then allocation in the sense when a process is being going on, so some set of resource instances are supposed to be allocated to your process. Something like the allocation of I comma j equal to k does means Pi was allocated with k number of instances of so I have missed with the k with here WATH with k number of instances of Rj. Okay, it's been allocated with k number of instances of resource type Rj. So still I required Rj of some more. How could you know that particular thing here in the sense need? If you take need, so this is one more data structure. If you take need, it is also n by m kind of matrix. indicating that need of I comma j will be equal to k does means pi still need k instances of resource type rj. Need will be gets acquired something like this: need of I comma j equal to maximum of I comma j minus allocation of I comma j. If you perform this one, still more what is the need for finishing of your job will be so acquired here. So these are the 4 data structures which are needed. And here within this particular need, you may be talk something about claim edge. So that is why need will be always represented claim. So claim edge will be comes into picture at this place. Don't write anything. So just I am giving you some information to you. Don't write anything here. So claim will be always taken in terms of need here. So therefore, these are very much required to be understand in terms of bankers algorithm. Okay. So bankers algorithm could always work on these 4 data structures and this claim edges. These are very much required for you. So